Hey there, scientists. Welcome to today's talk on dimensional analysis, also known as conversions or conversion factors. Cool thing about today's video is you're able to pause it, stop it, rewind it, fast forward it, in case you missed a point or want to go back over something. So feel free to do that as you watch this video. We're going to focus on doing our conversion factors much like you see on your class blue sheet. We can do problems that look like this. All sorts of metric conversions, centimeters to meters, liters to kiloliters, or grams to milligrams. Let's look at our first one, 2.45 centimeters converted into meters. We're going to start off every problem the same way, having a setup that looks similar to this with parentheses in the middle. We've got a top and a bottom where we're going to put our numerators and denominators. We have an equal sign. The S in this case will stand for our starting products. Where are we beginning? The middle part is our equivalency statement, our equal amounts. These two things have to be equal. And then our answer or our end product. So we'll write what we're starting with, 2.45 centimeters at the start. And next we'll go to the end. Where do we want to go to? What conversion is taking place? In this problem, it's centimeters into meters. We'll then say, all right, this is on top. We need it on top in our equal amount statement. And what needs to be canceled goes on the bottom. So numerator, denominator, or top and bottom. The bottom amounts, those units, centimeters, will be canceled. We're then looking for our relationship. 1 meter is 100 centimeters, right? Feel free to get this information from an actual meter stick, or you can go ahead and find it on our blue sheet with our metric conversions. When we do the math, 2.45 gets divided by 100 centimeters. That would then equal 0.0245 centimeters. Let's focus in on our equivalency statement. Right, this middle part that has to be equal. Any two things that are equal when divided equal 1. Hence the equivalent part of the equivalency statement. So the thing you put in the middle has to equal 1. Whether that is 100 centimeters in a meter, 24 hours in a day, 6 outs equal 1 inning in baseball, 100 yards equals a football field. You have your blue sheet as a reference. We can do problems like these or go back to our conversion collage. This has some equivalency statements on it too. We know that 1 kilogram equals 2.2 pounds, or on this we can see that 20.4 kilograms is equal to 45 pounds. Let's do another problem that maybe works a little better. Kids are always wondering, hey, how tall is the Leaning Tower of Pisa? Turns out it's 56 meters. How many feet is 56 meters? Let's draw it on the board like this. We have our big line to differentiate top and bottom. Parentheses in the middle with our equal sign. We'll designate the start, the equivalent part or statement, and our end or finish. We're starting with 56 meters here, the height of the tower. We want to convert that into feet. Feet will go at the end. Notice these are both on top in the same plane, both numerators. We'll put feet in our equivalency statement on the top where we need to convert, and meters on the bottom where they will eventually cancel. Then we could either look up, perhaps we know how many feet go into a meter. On our blue sheet, it tells us that 3.28 feet equals a meter. So I plug in those numbers. Right? That's the key to this relationship. How do meters and feet relate? Take those, plug them into your calculator, and you find that 56 times 3.28 is 183.68. And that'll be the way that we solve one of these problems. Let's take a look at one more. In this case, hey, how much mass does a spork have? It turns out it's around 25 grams. So how many kilograms would that be? 25 grams converted into kilograms. We have the same basic setup. We start out with a big long line, parentheses in the middle, an equal sign. We'll have a starting point where we begin, our equal amounts, and our answer or our end product. 25 grams is what we're starting with. We want to convert that into kilograms. Kilograms must go on the top. Grams need to go on the bottom to be canceled. And once again, we can refer to our blue sheet and we find, oh, okay, killi, 1 killi-unit, in this case 1 kilogram, would equal 1,000 of those base units. Just like earlier, centi, 100 centimeters equals one of our base units, 1 meter. So back here, 1 kilometer, or 1 kilogram, is 1,000 grams. Those are equal. Divide them and you get a 1, which makes it legal for us to take 25 grams times 1 and end up with the same thing. 25 divided by 1,000, right? Things on the top are divided by things on the bottom, and we get 0.025 kilograms. Please let me know if you have any questions about this. Look forward to working with you further in class. Thanks.